Hi, everyone. This recording is going to be regarding the IPv4 and IPv6, the subnetting and supernetting, and also the next topic for the advanced route summarization, and also some exercise for IPv6, the neighbor discovery protocol, and also the capture files of the IPv6 neighbor discovery, which we will refer it as ND for the detailed discussion of what's in there. So this is the two topics that we will cover. Today we'll cover the first topic of this document, Supernet and Subnet here. So if you click here and download the document, then let me show you what it will be. It will be in here. We will discuss this. And it would be nice if you can actually open another document or just print it out with this particular page, okay? This is the binary to decimal conversion table. It is very, very useful to help to understand the subnetting and supernetting concept. So quickly go through this. Binary A of the zeros is decimal 0. I just fill in the 0 in the front to make it look nice, that's all. So this is a decimal, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on and so forth. And that's the equivalence of the binary. Okay, of course you can use the financial or scientific calculator to do the conversion, but this gives you a pretty good top view of what it's like. As you can first pay attention to the first bit. If it's a 0, if we fix that and all the way to here, first bit is still 0. And then go to the second column, first bit is still 0 all the way. But this is the largest one. So 0, 1, 1, 1, 1, 1, 7 of the ones here. So the largest one. So if we fix the first bit to 0, then we know that the smallest one, of course, is 0. And the largest one will be 127. And the next one up, since the 0 is all gone, so, you know, the first one will be 1. And the smallest one, of course, is all zeros at the end, which will be equivalence of 128 in the decimal. And then if we keep looking down the table, you can take a look at it. Oh, okay, all the way to 191. And then go to the fourth column here. And this column is started with still 1, 1, right? And with 60, which is 191, and the largest one obviously become 255. So this table will give you kind of idea. If we say, hey, first bit, let's fix it to 0, then it will be from 0 to 127. And the next number, if we say we fix it to a 1, then we knew that if it's fixed to 1, it will be from 128 all the way to 255. So that's just a quick overview of how this table can tell you. And then we are going to go through all the examples using that page. So I'm going to switching this page on and off by showing that to you while we are discussing this concept of subnetting. All right, first, let's go through these notes that I put in here. So decimal is a base 10 number. It of course contains digits from 0 to 9. And when we reach 10, it will carry over. And when it's a base 2, that means we only have 0 and 1. And when you reach 2, it carry over, become 1, 0. And a bit is a byte, or you can say it's one word. And so it's, the range of the number is from 0 to 255, as you can see from the table I just showed you. Or you can say it's from a base 2, from binary, from 8 of the zeros to the largest one of 8 of the ones in the binary. That's 1 byte. So you can, of course, say 100 base 2, And of course, if you say 100 base 10, the way we say 100 or 215 or 1000 something, we are referring to base 10. So in the binary, we shouldn't say 100 base 2. We should say 100 base 2. And here we should say 100 base 16 or 100 base 8. Okay, that being said, let's take a look at this position of the importance of this bit position in the decimal value with the power of 2's. So if you have, for instance, if you have a binary value of 10101110, that's a base 2. How do you convert it to a decimal in the blue here? Again, the red means it's important notes. Black is a regular note, and then the blue one is the answer key. Okay, so just to remind you the reason why I use the different colors. So in here, the 0 position is always 1. Doesn't matter what that is. And the 1 position is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 4, 5, 6, 7. So that's the equivalence of the decimal value, the conversion, if you want to convert it. So then it will be 1 of the 0, which is 0, 2 of the 1 is 2, 4 of the 1 is 4, 8 of the 1 is 8, and so on and so forth. And then if you have 1 over 128, that's 128. That means if the 7th bit is a 1 here, it's 2 to the power of 7, which is 128. And if the 0 here, you don't even have to worry about it. 0 of anything is 0. And then if a 1 on the 5th place is 2 to the power of 5, which is 32. Therefore, you have to add a 32 into the first bit. And then go so on and so forth until you see another 1 here. And this 1, this is 1, 1, 1, 0. This 1 is actually equivalent of the numeric 8 in decimal, because 2 to the power of 3 place. So then it's 8. And of course, it is 2 to the power of 2 place, therefore it's 4. So you add it up to 174. So it's a simple calculation for you to refer to if you need to do that. Or you can just use financial calculator. It doesn't matter, okay? All right. And IPv6 addresses, it will be discussed next week in the next document. We're going to talk about all the IPv6 address scheme in the next video. And now here, let's define IPv4 here, class A, class B, class C. Let's define now what is the class A. We all know it has 32-bit. So then bit 0, bit 7, all the way, whatever, this is 8-bit in here, right? And then we have 24-bit here. So it's first bit, dot, second bit, dot, third bit, dot, fourth bit. Class A means the first byte. Okay, the first byte is network. Second byte here, this 8-bit here, this 8-bit here, this 8-bit here, right? Second byte, third byte, fourth byte are host. Remember, we've been talking about this a lot in class. A 32-bit IPv4 address, they have 2 information in there. The first part is whatever portion of the IP represents the network. And then the rest of those IP address will represent the host. That's the most important information you remember in the IPv4 and also in v6 addresses. So we define class A is that if we fix the first bit to 0. If we fix first bit to 0, and again, if you refer to this table to see it again, first bit, if it's a 0, then as you know, the first 2 columns from 0 to 127 is all 0. Therefore, you knew that if we fix the first bit to 0, the smallest one will be 0, and the largest one will be 0 with 0 and 7 of the ones. That's the largest one, which according to whatever the calculation or the handout I gave you. So class A here, according to this definition, is from 0 to the largest one, 127. However, the 0, 000 is reserved as a keyword for any, or you can refer to internet. If you do a route print, and you will see 0, 0 in there. For instance, if you go to your computer and if you go to the command prompt and you would do something like route print -4 to see IPv4. And you can see that, hey, all right, 0, 0, 0, 0, 0, 0, 0, 0, hey, that's your default gateway. Default gateway, that means that if you don't find any specific route here, you are going to use that address, 192.168.1.1, and my number is 209. I'm going to use the 1.1 to go to the internet. Unless I have a more specific route I can find down below, then I will follow the specific route, which we've been discussing for the past 5-6 weeks. So this is like a default gateway, and that means what? Internet. When it's not in your specific route you want to go to, well, it pretty much will be in the internet. That's your last resort. So that's your default gateway, and we use the 0.0.0 to represent that. So we do not say 0 is class A. It's excluded from that. And again, the 127 dot whatever is for loopback. So we do not say that's class A either. So therefore, class A is from first byte between 1 to 126. Okay, that's class A. All right. So if the first byte is between 1 to 126, .x.y.z, and xyz will be any number between 0 to 255, then it's in the class A. Okay, that's the class A address. Now, okay, next one. When the 0 has been, oh, use that, depleted, then the next up is a 1 here. A 1, and then same definition. If there's 0 here, that's a class B. So you will see 1, 0. So if we take a look at 1, 0 in here, so you say next, we have to fix it to 1 here. So once we fix to 1, and whenever it's 0, so 1, 0, and you can see, oh, it started from 128, right? And the 1, 0, 1, 0 all the way to largest one is 1, 0, and 6 ones here, and it's 199. I'm sorry, 191. And the 192 is no longer 1, 0, it's 1, 1 now. So therefore, by the definition, class B is started with 190. It started with 128, and it ended at 191. Just go by the definition here, okay? And then let's move on to class C. And once we use up the 1 and we use up all the zeros here, we have to put the 1 in here. That's the last resort. So 1, 1, and the next one, same definition. If the third bit is 0, then it's class C. So third bit is 0. So let's take a look at it. Oh, okay. It's 110, and you can see, oh, 10, we just use it up to 191, and continuously, 192 will be 110, the smallest number. So class C started with the 192. 110, 110, 110, go all the way to 223, and you can tell from here, yeah. So this is 110, the last number, and that's 223. So that's a class C. Well, you probably already figured out, then class D will be starting from here, 224. That's a multicast address, right? By the definition, 110 has been used up. Next up is 111. So fourth bit is 0, that's multicast. So 1110, 1110, 1110, go all the way to here. This is the largest one, 1110. Okay, so let me highlight it. I don't want to listen to me, but anyway, yeah. Okay, so this is 1110, largest one. So you know the multicast class. D is from 224 all the way to 239, and then 240, starting from that, is the class E, which is experimental. We don't use that anymore. So this is the definition, scientific definition of class A, B, C, D, and E. All right. So that's a quick rundown for class A, B, C, class 4 address. And this is not efficient because you know that the smallest one, it will be a class C. A class C, if you look at that, it will be in a class C network, you will see, let's see, you will see the network address look like this. Yeah, you will see network is network, 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 and the host, that's class C, like 192.168.1.x. X is from 0 to 255. So the smallest network is 256. Of course, you cannot use 0. You cannot use last one broadcast 255. Well, then the smallest host number you put in was still 254. It's kind of wasteful, not efficient. That's why we have to create subnet mask to resolve the problem. Okay. So what we already learned, the definition of class ABC now is so-called class 4. And now we're going to make it classless, meaning that we're going to use a subnet mask to actually make it more efficient. And the subnet mask is the way that we go to distinguish which part of the IP is network, which part of the IP is the host. That's the whole purpose, okay? So in the basic networking course, so that's why we use the subnet mask to define a more detail of how to subnet it, to increase the number of network with the reduced host per network, or we supernet it by combining a network to increase the host per network. You can think about a network like a street, like a Grand Avenue, and it has, say, 256 houses on that particular network on the Grand. And then if we subnet, that means we cut the network to 2. So we can call it Grand West, Grand East. Well, then you still have 256 houses there. So if you cut it to half, Grand West will be the first 128, from 0 to 128, and this Grand East, the second part of the newly created network or the street, you will have another half of the houses. So then you are creating more network at the cost of less hosts available per network. So that is subnetting. And if you supernet, that means you combine. If you have Grand East, Grand West, each one has 250 houses. And you say, hey, let's combine it because I just need to for some reason. Okay, I'm doing, mostly is from the ISP. They want to do a route aggregations for more efficient routing. Instead of comparing so many routing entries in the routing table, they can just combine it and say, oh, okay, if your IP are all in this super big network, you're going to go to East Coast because that's where I assign my customers' IP address in there. We will go into supernetting later, but a quick concept on that is that you have Grand West, Grand East. Each one has 256 houses. You can combine them and change the street sign. Say, hey, instead of Grand West, Grand East, you just change it, say, Super Grand, or just one word, Grand Avenue. And then house number from the first one to 255. And then the second from 0 to 255, we ignore, don't worry about the first number or last number. We just go and add those houses into one. You change your address instead of say Grand West or Grand East. You just say, I'm Grand, house number so-and-so, but you have 512 numbers there. It's called supernetting. So it's logical. One is subnetting, cut the houses into half, available house number to half. So we create more network. Or you combine the network together with the increase, combine all the houses on network to make it a larger network. Okay, so that's it for the Subnet SuperNet quick overview. And we're going to introduce a shorthand notation for subnet mask. 25500 is a /8 because there are 8 of those ones in your subnet mask. And of course, 255.255.0.0, the one that we commonly deal with, is a /16 because you have 16 of the ones in there. And the class C by default, 255.255.255.0 is a /24 network. And be aware though, it doesn't have to be /A/16/24. It can be /anything, okay? It's between 0, it's from, usually when we don't do a /0. We don't do /1 either. Most likely you will see /9, 10, 11, go all the way to /31, okay? And /31 is a special one. I mentioned that in my document somewhere. Only for some point-to-point usage. Most likely you won't see that. The smallest one is /30, which we will take a look into it very soon. Okay, now number 6 note. We're going to look at this. 10.10.0/24. The first 3 byte is network, and 0 is the smallest host ID number. So which reserved to represent the whole network. So if you want to say, hey, the whole network of 10.10.10. from 0 to 255, you are not going to use such a long sentences to describe that network. And computer doesn't know that either. You have to say 10.10.10/24, and that will represent the whole thing. So if you take a look at this one, if you take a look at the route print table that I showed you before, you can see that. So this is a /8. So you see, your loopback is 127.0.0.0. That means anything on 127, and that's a /8. That's the way you represent the whole thing here. Okay. And if you want to represent 192.168.1 network, you use the .0 smallest number, and use the /24 to represent the whole thing. Okay, so that is the way to represent the whole thing. If you want to represent just one host, you will put down 255.255.255.255. Okay, all right. Now, when we connect hosts to a layer 2 switch, it is better to give all the hosts with the same layer 3 IP network address. And then you have to make sure that each host on that same network must have the same network ID number, same network portion number, and with a unique host number. This way, all hosts can communicate without a router and without IP duplicate error. And we did have an exercise a couple of weeks ago, topic 3, basic routing. If you can remember, you can go back there to review it to illustrate this concept already. Okay. For more advanced subnetting and supernetting, we need to think in binary. All right. So the subnet mask is a 32-bit in length. All right. And by the way, before I go into any further discussion, I would like to talk about number 10 here first. If your company has less than 250 sites, the 10.10.1.0/24, including 250 hosts for this network, it can be used for your site 1. Okay? You have less than 250 sites, each site has less than 250. You can actually give out 200, you can get out a lot of IPs. And let's just use a simple method. We use the third byte, 10.10.0, 10.10.1, 10.10.2, 10.10.3, all the way to 10.10.255. So we can have 256 or 250 of those different subnets. And those 250 plus subnets, each can have 250 plus hosts. That's a lot. Plus, it's 10.10.1 that we're using, 10.10 we're using for that. We're changing the third byte to create 256 network. If you need more than that, you can use 10.9 and get another 256. You can use 10.8 to get another 256. We have almost no need to use the complicated subnet that we are going through right now, except that I have seen two of those companies that I consulted with. They are using a very unusual subnet mask and a Supernet. One of them is a university in the El Monte area, where they have supernetted 192.168.0 and 192.168.1 into one supernetting. And the other one is the hospital in the Pomona area, where they actually subnetted to a /10. And that makes things complicated, unnecessarily complicated. But to pass the test, CCNA, or just to show your proficiency in the subnetting and supernetting concept, we just have to spend time to go through that. As far as the practical uses of this, you don't really need to use a sophisticated subnetting method to implement it in your corporate network. Okay, So I just have to say that first. And number 8, we go back that. So you have to understand what is a subnet mask, the rule on that. So the subnet mask is a 32-bit, just like the same length of your IPv4 address. It will start with a 1, and it can have as many zeros, as many ones continuously keep going. Bit 1 subnet mask can be 1, and then bit number 2 can be 1, 1, 1, 1, 1, 1, 1, 1. When you see a 0 in your subnet mask, you have to 0 all the way. That's the rule, okay? And what does it mean? So in the basic class, we say 255. We start with a 255, and whenever you see a 0, you have to be 0 to the end. It's the same rule. 255 is 8 of the ones. So if you say 255,000, that means it's a /8. You got 8 of the ones in there, and you got all the 0. Once you see a 0, you 0 all the way to the end. So yeah, if it perfectly complies to this rule. You can never say your subnet mask is 255.0.255.0, and that's not legal, okay? It has to be 255 and continuously with the 255 because it's all 1, keep going. And then once you see a 0, it must be 0 all the way, okay? And what does it mean? It means that this will override your default IP class 4 definitions. So it says that the counter IP address bit, okay, of your subnet mask, okay? If your subnet mask is a 1, the counterpart of the IP, it represents the network. The counter IP address bit represents the host of that host if the corresponding counter subnet mask bit is 0, okay? So let's take a look at one of those examples quickly, and we'll go back to number 9. We're going to see this samples really quick. So we will take a look at this one. IP address, we are going to just think about IP address in binary. So an IP address of 200.200.200.0 actually is here, 1100.1000, and I'm not going to read it, just keep going. It's 200, 200, 200, Subnet mask is the second line here. So this is subnet mask. You can have as many ones as you want, but once you see a 0, you 0 all the way. And what I said before was that the counterpart of the subnet mask, this one, this is the IP part, which it has a counterpart, meaning corresponding, if you want to call it. So you have one IP bit and you have one IP subnet mask actually matching it, okay? And you have the second bit is 1 and the subnet mask is 1. So this many 25 total actually, subnet mask is all 1. That means this 25 bit of the IP here, got some trouble to highlight it, but anyways, you know that the 25 bit of those IP, okay? Those 25 bits of IP, because they're counterpart of the subnet mask or the corresponding mask is a 1. Therefore, this is a network. And so the network is 200, 200, 200, and the first bit 0 of the first byte. Because you still have, it's not cut in the decimal point where we can easily say that, okay? So we have to go by the bit. Just think about bit. This network is 25 bit, and its network is 1100, 1000, and keep reading it, and then with that 0 here at the end. That's the network, and that's the host ID. So this is the same network. This is the network. ID is 1. And this is a network, and the ID is 2. So this is 1, 2, 3, 4, all the way, okay? All the way to 127. And you take a look at it. If you go to 128, look at the handout, you will know that 128 is actually a 1 in here. So therefore, this 1 and the 0 is no longer in the same network. That's why 127 is the last IP address of this network. Okay, we will get into this example again, but let me just give you a preview when we discuss the principle first. All right, so let's take a look at this number 9 again. So the meaning of subnet mask is that it has a corresponding part of the subnet mask. If the subnet mask is 1, that particular bit of the IP represents a network. If the subnet mask is 0, then that IP bit corresponding to the 0 subnet mask, it belongs to the host. And you don't care whether it's what number it is for the decimal, because the decimal 200, it doesn't make sense. The first from 0 to 127 maybe one network, and from the rest maybe from different networks. So it will never make any sense. We will use a binary to define the concept of what's the network. And then we use the decimal to answer the question. And we will do the exercise for that. So if your company, this is one we already discussed, so it's very important that you know how to apply the network in a logical way that you can carry it out. That's the most important thing, number 10. When we flip that or change the first bit subnet mask, then the corresponding IP bit will become network bit. Therefore, the IP bit 0 and 1, it become different network. So what I say in this one is better off that we will have to look at. We will have to look at the example now. Okay. So be aware that you have this page handy, and let's take a look at this. As you know, the 200 is actually Class C network. So if you take a look at this, this 200, okay, that's 0/24. Originally, it's 200/24, and that's a class C address by default. And so of course the subnet mask is 255.255.255.0. And now we do subnet. The subnet means that you flipping. Remember in the document when we were just discussing, we said flipping one bit, right? So originally this subnet mask is 0. Number the first bit of the last byte is 0 for the class C. If we flip it or we change it from 0 to 1, well, we could do that because you see the rule, the only rule on a subnet mask says that you start with a 1 and you can have as many 1 as you want. So hey, if I change this 0 to 1, I change the subnet mask from 255.255.255.0, I change that to 128, that's perfectly okay. I comply to the rule. But what has been changed is the meaning of that. The counter bit here on the IP, this is the IP address. 200.0, of course, there's a zeros here. And you think about it, because your subnet mask has been changed from 0 to 1. So this 0 originally is part of the host. And now it becomes network, okay? So if this first bit becomes network, then let's take a look at this one. Take a look at here, and you see, hey, all right, first bit 0. So we look at this page as the first byte, So first byte is from 0 to 255, right? The first byte. The first byte of the IP address. So think about this as the IP address of this last byte, okay? And you see, originally the whole thing, the whole from 0 to 256, if it's a /24, it's belong to one network. And now you say the first bit is network now instead of host. So 0 and 1, they still stay on the same network. It's the newly created 0, right? Network 25th bit is 0. That's the same network. And if you go to 128, the first bit is a 1 now. So therefore, you see that in here, the smallest number of, if you fix the number 25th bit to 0, you go all the way, the largest one in your handout there, it says 0 and 7 ones, that's 127. Well, that is one network because this is the largest host you can have for this network. If you fix this 0 as the network, right? And the next group of the network will be 1 in here, right? 1 with 70, that's the smallest number of this newly created network. And that will be 200, 200, 200, 128. And the largest one, if you keep going, it will be 1, and then with 7 ones, the largest one is 255. So when we change the number 25th bit, okay, the subnet mask from a 0 to 1, we tell the computer that number 25th bit is now representing part of the network. Therefore, your host ID, if it's 200, 200, 200, 0, 1, 2, 3, 4, 5, 6, all the way to 127, you are still happily in one network. However, you are 128 to 255, they can no longer communicate with host ID 200, 200, 200 from 0 to 127 because they are now, according to the definition created network by the subnet mask, you are in different network now. Just like 10.10.1 and 10.10.2/24, you are in different network because of the subnet mask of number 25th bit already been reallocated as instead of part of your host to become a new network number or a part of the network. So originally it's a 24-bit network and now it's 25-bit network. And the number 24-bit, everyone is the same. However, the 25th bit, 1 of course is not the same as 0. Therefore, we created 2 networks, and each network will have half of the IP address. From 0 to 127, the first half become Grand West, and Grand East is from 128 to 255 because we define this as a new network because of subnet mask. So you can think about it as you have total of 256 houses. Just go to the house outside of the house plate, the address. You're going to put in binary number, only binary number. Okay, house 0, you will put it into this number. Okay, and then house 1, you put in this number. House 2, you put in this number. House 3, you put in this number. And you're not going to put in decimal. Okay, just keep putting in binary number. And you knew that this is equals 4. And you put in all the way house to 127, and you put house 128 like that, all the way to house 132 like that, and house 255 like that. So that's okay. And then you will say, hey, the first 24-bit, you are going to just say, put a subnet mask in now. Say 111111111. Originally is 1 and with all 8 zeros at the end. Okay. So then you knew that, oh, everyone is on the same network, right? So the street name is the first 24-bit, and this is the house number. Now, if we go there and change the subnet mask of each house to the 25th one, and the subnet mask instead of 0, we change it to 1, then everybody will know, okay, here, this is a street called whatever it is, 11011, and now it doesn't stop here as a street. The street is called with the number 25th bit of 0. So this is separated out. This is the network, and this is the host. Therefore, this network 0 that's created, it's no longer on the same street of that. We actually successfully divided into 2 networks, and each network have half of the house. Okay. So that's the summary of what we have talked about, all right? Now we are going to go on to the next example here. If we keep doing it, we flip the other 0. You can see that we have a 0 here. The 25, 26, right? It's from /24, we change that to /25. What about we keep doing it? Let me just change from a /24 to /26, or even from /25 to 26, same thing, right? So we are going to put in 1 in the subnet mask. So what it means is that the 25th and 26th IP bit in the /24 is part of the host, and now it becomes part of the network. So the network has become 26-bit /26. Therefore, 00 is a new network. 01 is another new network. 10 is another third new network. And 11 is the fourth new network. And that's it. There's no more combination you can put. So you flip in 2 bits. You can put in 00, 01, 1011. You don't put it in. Actually, it's a total of the 256. We just divide it. So if we go back in to take a look at here, you can see 00 for the whole column 1, and 01 for the column 2, 10 for column 3, 11 for column 4. And you can see 00 all the way to the last one, okay? And 01 to the second one, and 10 and 11. So it's from 0 to 63, the first new network. And then from 64 to 127 is the newly created 01, the 25th bit 0 and 26-bit 1, the network, second new network. And the third network started with the 10 is from actually 128 to 191, right? Oops. And then the last one is from 192 to 255. So we created 4 sets of network. So if you take a look at it here, you see that 00. If you fix it with 00, right? And this is subnet mask. Okay, so don't be confused. The red one is subnet mask here. It tells you that, hey, these 2 bits now is network. So everyone in the first 24 bit are the same, 200, 200, 200. However, now it's different now. 200, 200, 200.0 / 26 means that its first IP address is .0. First usable one is 200, 200, 200.1. Last IP for broadcast for this network is 200, 200, 200.63. Why? Because this network of the 00, the largest one is 6 of the ones here, and 00111111 is here. This one, 00, the largest one is 63. Therefore, if we change from /24 to /26, the first network will be represented as 200.200.200.0 / 26. The broadcast for this network would be 200, 200, 200.63, okay, and /26. So that's the broadcast address. And the next one, it will be 200, 200, 200.64, because see, that's the smallest number. If you take a look at it here, this is the smallest number that we have, right? For the 01 network, we fixed the network as a 01. So 64 is the smallest for this group of the new network that's been grouped together or created, because we borrowed the 2-bit, right, from the subnet mask. And the first network IP that can be used for the host belong to this network will be 65, and then 66, and keep going on. You can look at the handout for the detail until you hit the largest one, which is in the 01 network. The largest one is 6 of the ones here, which is 127. So the broadcast address for the network of 200, 200, 200.64 / 26 will be 200, 200.200.127 / 26. And so on and so forth. The third group will be 200, 200, 200.128 / 26, and the broadcast address will be 191, because, you know, we fix it at 10 here, right, the network. And the largest one will be that. And the last group, the smallest number, will be starting with the 11, this new group, right, the fourth group. And the smallest one will be 192 here. And then the largest one, obviously, it will be 255 here. So this one summarizes that the 4 networks created are 0 / 26, 64 / 26, 128 / 26, 192 / 26, and you'll be able to know the broadcast address. And each network will have 64 minus 2 hosts, which is 1/4, because you created 4 networks. And each network, it's total 256, no matter how you do it. You divide it, you chop one street with 256, you chop it down to half and half. It's 2 networks you created, and then you have 128 each. And then if you chop it to half again, then you created 4 networks. Then each network will have 1/4, right? 64 minus 2 hosts that is available per network. So a total of 206 byte is fixed. And you can allocate more network and with less host, or the other way around, okay? or you can have less network with more hosts, but it combines to a total number of the magical 256 per byte. Okay. All right, so let's go back to the discussion of, I believe we are on the bullet number. Okay, 11. So if we flip the first bit in a subnet mask, and we just did a class C. Class B, class A is the same way, and we will deal with that later. So no matter what, for that byte, the first bit in the subnet mask, if we flip it, I mean, we change it from either 0 or 1 or 1 or 0, the other way around. If we change it from 0 to become and 1, become if we flip it to from 0 to 1, like what we just discussed, and so the IP bit 0 and 1, it become different network as we discussed. So then we just created 2 new subnetwork, and each network will have half the host. And we also discussed if we changed it from /24 to /26. Now we flip 2 bits of subnet mask from 0 to 1. Then we will create 4 network, right? And each one will with 64 available IP number. Yeah. All right, so number 12, the total number of a byte is 256. No, we already discussed that. And if you multiply the new network number created and with the host available per network, it must and it has to equal to 256. Then you do that right. So if we say, hey, I use let's do it in our head and say, hey, if I did a /27, what would happen? A /27 means that I flip 3 bits. So then I have 2 to the power 3 of the new combination for my new network, which is 8 of them. And then 8, so each one would have 2 to the power 5, 32 available hosts. And so that you added you multiply the A network plus times 32, it equals 256. Yeah. Okay, so we want to look at that again and revisit this concept. And we usually will not send it to /32 because it means itself. Okay. The 128 network with 2 hosts are not usually implemented. The so-called so-called 128 means that it's a /31. Okay, I probably should change this document. I would say that the /31 network is not usually implemented. I'll change that. So don't worry about that 128. I'll change that. The /31. The /31 network was 2 hosts available because you see, /31, that means /31 means in your IP, the first 31 bit represents the network. Only the last bit is the host. So last bit is the host. A bit can only hold 0 or 1. Therefore, each network, you can only have 2 hosts. The 2 host number, one represent the whole network and one for broadcast. You cannot legally use any host ID for anyone. But in reality, there are some people deploy that in the point-to-point, and it worked. Okay, so I cannot say that's wrong, but it does work in a real-life scenario. Okay, but usually we don't do a /31. In the ISP that you are going to ask them for the smallest number, it would be a /30 network. I mean, we just take a look at it without looking at any kind of picture or graphics to help us, but just think about it. /30 means that
well, IP has 32-bit, right? So 32-bit slash 30 means that first 30-bit of the IP represents a network. So then each network only leave you 2 bits, the last 2 bits as a host. So the bit can be either 00, 01, 10, 11. And 00 you cannot use because it represents the particular network. 11 is for the broadcast. You can only use the 01 and 10. So you can only have 2 hosts. So that's why it's the most efficient way for an ISP to give you a static IP. They will say, okay, you can get one static IP, then I will give you a slash 30 of the global routable IP address. Because every network your ISP give out to you has to be unique to one user. If they give you more IP address that you don't use, you don't want to pay for, then it's a waste for them. So you can buy one IP address. But if you want to buy 2 IP address, they will say, no, the next level up is you buy 5 IPs. And they say, hey, why? And think about it with the slash 30 again, because 2-bit for the host, 2 to the power 2, you can have 4 combination, right? Minus the network and minus the broadcast. And minus 1 is the default gateway that the ISP has to connect it to you. So you got to use 1. So they charge you 1 instead of they say, I charge you 2. I say, no, I only got 1 because they have your default gateway, right? So the next level up, of course, is the slash 29. Slash 29 means that, hey, you have actually 3-bit for the host. The 3-bit for the host, and if you put a combination on the 3 bits, you have 8 combinations, right? Meaning it's 000, 001. If I want to type it up, it will be something like this. Yeah, why not? Let me just type it up. And we will say, it's a 00, I think 000, and then it's 001, and then it's 010, and then it's 100, right? And then it's 101, and it's 110, and then 111. I think I missed one of them here. 0, 1, 2. Oh, I don't have 3. Okay, so I'm going to do it here. 0, 1, 1. Right? Okay. So if you take a look at this, the 3-bit, the last 3-bit, no matter what's in the front, the first, we're talking about slash 29. We don't care about the first 29-bit. That's the ISP's network ID that they gave you. It's a fixed, okay? It's a fixed portion of ID. You want a host number. You say, I want to buy host from you, static IP. And you cannot use the first one. And you cannot use the last one. So it gave you 1, 2, 3, 4, 5, 6 available number. And usually the first one is the default gateway for you. Your ISP will connect. So then your next one is 5. So that's why if you call your ISP, they'll tell you, hey, 5 is the maximum number you can get. Okay, for not the maximum number, but it's the next level up of the IP number. If you can buy 1 IP, or you can buy 5 IP. If you want to buy just 3 IP, you still have to pay for the 5 because you are the only one who can use that network. The ISP cannot give that ID to someone else to use. They have to route it to your network, okay? So that is the reason why. All right. So now this last comment here is when we change, it's a contiguous 1 subnet mask and then 0 all the way, right? So now if we change this time, we changed from 1 to 0. That means we actually, originally the counterpart, that particular bit is part of 1, right? It's 1, so it's part of the network. Now if we change that to 0, that means that bit, instead of becoming a network, is now part of the host. Therefore the host just got increased the number. So it's called Supernet. We increased it. Okay. All right, so this is the page for your reference. And we already talked about this from /24 to /25. And we also talk about /24 to 26. And now we're going to do one more from 24 to 27. So if we take a look at that, from 24 to 27, then actually we flip 3 bits to create subnet, right? And those 3 bits, and you can see that use the same example that we remember the previous discussion when I was talking about you can get the IP address from your ISP. The available host number, the 3-bit is total 8 numbers, and you can not use the first last one, and they will use one of the default gateway, so you can find IP. We are looking at the host portion. And now we are looking at the number portion. It's still 3 bits, okay? 3-bit, the combination is either, same thing, the one as I type it for you, 000, 001, 100, 011, so on and so forth, all the way to 111 here, all the way to the 111 in here, okay? So if we take a look at this one, for some reason, my computer has a lag behind type of response on that. So let me just show you this one. So we are taking a look at a /27, right? /27, the first 3-bit here, 24, 25, 26, 27. So we flip 3 bits in here. So let me just move it to the first part. So that's easier for you to see that. So if we take a look at this one, you'll see we changed the first 3-bit into a network. So first 3-bit now it becomes a network. So if we take a look at here now again, okay, now we say the 3-bit is network. All right. So the first 3-bit here, this is network, the first 3-bit. The first 3-bit 000 is a network. Okay, look at 000 all the way to 000. Okay, to 31. You see, it's 000. So from here, from 0 to 31, all the way here. From 0 to 31 decimal point, and your first 3-bit here, it's always 0. So that's the first available network. And the second available network is 001. And it's from the decimal of 32 to 64. According to definition, right? The best way to deal with subnet mask and supernet is go by their definition. That's the best way and the only way to deal with, if it's mathematically a function, you have to deal with definition instead of memorizing all the rule, which is derived from the basic definition. So when we learn about that, we have to learn the basic definition. So the next available one will be 010. And it's from 64 all the way to, of course, 95. It's a 010, right? 010 is the last one. And then the next one will be 011, right? So, you know, your paper here, your paper of this particular page, it will be like, okay, the first 1/8, the first half of the first column, it becomes 2 network. And second column is another 2 column. And the third column is network number 5 and 6, and number 7 and 8 is the fourth column here. You see 110 here. This is a 110 network, and then the 111 network. That's the last network. So we created 8 network by defining this 4th byte of the IP. Say the first 3-bit. Originally, you are a happy big family of a /24, but now if I say instead of every one host of these 256 numbers, instead of /24 subnet mask, you got a /27. Then everyone will check their first 3-bit of this byte. Originally, it's just 1 byte of the host, and now you say, hey, the first 3-bit now is part of the network now. So my host ID is last 5 bit. Therefore, you know, we created 8 networks just by the definition. Okay.
All right, so now this is what we're going to do now for this subnetting a class C network. So we are using different one now. We use 192.168. The Cisco question test could be like this, and also in my question too. And I can tell you that whenever you do the practice test or real test or just the homework assignment, I just use the same set of the IP, same question. I will not change the question. I have no intention to make it complicated, and nor do I think it's so important for you to be so fluent, so familiar with all this intensive subnet mask. So I want you to get familiar with the number and know the theory and be able to do the exercise. And then later on, if you really encounter a sophisticated subnet situation, you can always go back to these fundamental examples and then get your answer correctly. Okay, and of course, you can also use the internet tool to help you to find out the answer. But in here, a host with 192.168.1.34/29, we never did 29, so we did a 29 here, and I'll tell you how to solve the problem. Belongs to subnet what? You say, well, how would I know which network it belongs to? I mean, we have been doing 3 examples, but I haven't done /28, and now you're asking me /29. So no worry, we just do this. We put the IP here, 192.168.1.134. Okay, so the focus is on the 4th byte. So I'm not going to convert the 192.168 into binary, and you knew that it has to be the same. And the network /29 actually cut it to some degree, cut the first 5 bit to become network, and the 3 bit become host, right? So in the document, I told you that, hey, the 4th bit, the 4th row, this is subnet mask. Subnet mask define your IP address. Which portion is network, which portion is host? That's what we've been talking, right? You will write down the question 134 here and break it down according to my handout or use financial calculator, put it to 100000110, and that's 134. You have to sync in binary. And /29 means that this is 24, 25, 26, 27, 28, 29. So you have 29 of the ones. Just go by the question that they gave you. So, and then you draw a line. And you put down the same thing here on the 2nd line, 3rd lines. And let me ask you, for this network, 192.168.1.10000, what's the smallest number? The smallest number is put down 30 here. And then, so you look at this 1 with 7 0 in your handout, it equals 128. And what's the biggest one for this network of 10000? The biggest one, of course, is 111 here. And you look at the conversion table, it's 135. It's the largest host ID number. Therefore, you can say the network smallest IP is 128, which reserved to represent the network. And the broadcast address is 135, all right? And so the host, the 1.134 belong to the IP range of 128 to 135. And another more technical way to say it is the host belongs to 192.168.128/29 because 128 is the smallest number with the the 29 is the representation for the network that it belongs to. And the broadcast address will be 192.168.1.135. And you can say it's 255.255.255.248 because 248 actually is a /29, okay? And then of course, we will then have a quick way of figuring out at the end of the summary. And I'll leave this part for you to digest yourself. I'll go through that, but if you didn't get it the first time, don't be frustrated. It took me a long time to get the shortcut to make any sense to me, okay? So we're not going to talk about the shortcut for now until we cover the whole document. Okay, so now we're going to subnet a class B network. We just subnet a class C, right? Then again, the question is, 172.16.00/16. Yeah, I'm going to subnet it to /22. What would that happen? What it will create what? So let's take a look at it. Again, we don't worry too much. We just go ahead and write it down for the definition. Try to figure it out. We just do 192.16.00. Okay, so 00, and then we say /22. So you are going to put in here the subnet mask. I use the brown color, right? So subnet mask is all the way to here. This is once. So and then you draw a line. All right. This part is network, and this part is host. All right. So then this is the question 172.16.00. So you wrote it down here, right? And I only write down the third and the fourth byte, okay? Because the third byte here and the fourth byte is the question, is the focus. The first 2 bytes, we don't really care. It started 172.16 anyways, okay? So the third byte and the fourth byte, if you take a look at it, the first network, of course, is all zeros here, right? And it's a /22. So 172.16.00/22 itself is the first network, right? How about the second network? The second network will be a 01. We just flip 1 bit here, right? 01. And the smallest number is all zeros. So therefore, the next one is 172.16.40. And then the third one, of course, then you can see the similarity now here. It's a 1 here. And well, if I skip this one, then the next one is 10 here. And 1000 here is the 8, right? And then the next one, your network will be 11 here, right? So the first network, second network, third network, fourth network. And the 11 here, of course, it will be 12, right? You can use a financial calculator, or if you're good at math, it's 2 to the power 3 plus, which is 8 plus 4, so it's 12, right? So you knew that we can create a lot of network here, and I just drew 4 of them here, 0, 4, 8, 12. Actually, it's an incremental of, of the 4s in there. So you can see that it has, you have, think about it, you have 6 places to hold a network. You have 6 newly created network in here. 6 places to hold it. And all the combination, the first bit, you have 0 and 1, 2 choices. Second bit, 2 choices. Third bit, 2 choices, 2 choices, 2 choices, 2 choices. So it's a combination of 2 and 2 and 2 and 2 and 2 and 2. So it's 2 to the power of 6. 2 to the power of 6 is 64 combination. And the host for each one of them, for the host portion, it's a 00 and 01, 1011. So there are 4 of them, 4 choices. 4 choices, each one was 256. That's why you have here, you have 10 bits. The 2 to the power 1, 2 to the power 2, and 2 to the power 3, 4, 5, 6, 7. This is 2 to the power 8 combination here, and this is 2 to the power of 2 combination here. So you have 2 to the power of 10 combination per network, which is 1024, right? 2 to the power 10 is 1024. So you created, actually here, you will create 64 possible network if you use a /22 here from a class B, okay? So it tells you that it creates 2 to the power 6, 64 minus 2 network, okay? And if we go by the RFC, then we cannot use the 00 or 01 network here. What it says is that you cannot use the first one, 00. This is a newly created subnet, 00s in here. And the largest one is the 01s here, all of the ones in here. And you cannot use either one of them. You cannot use 172.16.252. You cannot use 172.16.0.0/24. This is just by the RFC. Nobody in the real world or the manufacturer follows that. So my quiz question will never test you a knowledge on that. But sometimes I have seen some network administrator making a scene or making a big deal out of the knowledge of this with this junior administrator. So I just want to mention it so that you know it's perfectly okay to use it, but according to the RFC, it's not a legal subnet to use. No big deal, okay? But you have to know the rule says the newly created subnet mask, subnet, it cannot be all zeros or all one. The newly created network. And here, this is a newly created network, right? Originally, it's part of the host, and now it become a network, right? And this newly created first network, it started with all zeros, and the second network, the .4 here, is actually not all zeros, right? And this is not all zero. This is not all zero either. All the way to 248, this is not all zero either, but and not all one either. But the last one, the 252 here, this network, this newly created network is all ones, therefore it's not legal according to the old obsoleted RFC. Okay, all the router will work if you implement these numbers. All right, so the next one, the next topic will be find the first subnet. This from the same example. Find the first subnet and its broadcast IP address. So let's take a look at it. The subnet here, again, this is the same thing that we actually create that. I think I accidentally deleted a 0 in here. Yeah, so I'm going to put a 0 back in here. Okay, that's better. All right, so again, it's a /22. So we cut a line here, and then you always want to do it this way, okay? This is the only way I would ask you to do during the class, during the test, during everything. Later on, when you figure out your own way of doing your subnetting, supernetting, feel free to use it. But for now, stick with the definition. And I constantly forget about the shortcut when I spend time and get familiar with all the shortcut and all the tricks. But after a while, you forget about it. And the only thing that you will not forget is the definition, okay? All right, so this is subnet mask, and we drew that and make sure we know which part is network, which part is host. And so that we are going to say how many of the hosts per network. So we say the first network is here, okay? We just look at the first network, just one network, 172.16.0.0/22, right? So that's in here, 172.16.0.0 and /22. The smallest network number to represent this network, of course, is 0 all the way, so 0, 0. Good. Now the largest one, the largest host is 1, 1, and then 255. That means 8 of the ones. Okay. So in decimal is 3.255. So this network, including from 172.16 from .0 all the way to 172.16.3.255. Okay. So in here it tells you that so you can see that from this particular table or chart you want to say, the smallest one is 0, 0 here, and large one is 3.255. So that means in here you can take a look at the note. 172.16.0.0 to 172.16.3.255/22. All of those host IP address belong to the 172.16.0.0/22. Okay, so so this particular network, if you write it this way, that means it's the whole network of from the 00 all the way to 3.255. Okay, and 3.255 is the broadcast, and the 00 represent the network. So the host ID is from the 00 all the way to 3.255 in here. So you can derive from here. Okay. And if we want to find Well, some can argue that this is not a valid IP address. So I will not test you this, okay? So this is just when some of those senior administrators kind of like want to make a big deal out of this RFC, and you better understand it, because the the 172.16.0.0, the subnet mask, the newly created network here, according to the new subnet mask, the newly created network all zeros. So you can say that it's not a valid IP address. I will definitely not test you this in my class, okay? And all right, so let's take a look at the second smallest subnet that we created. So the first, of course, is 172.16.0.0, and we just flip 6 of the subnet masks from 0 to 1s. And the smallest, the second smallest is, of course, is 0, 1 here. So it's the 4, right? And the third network, the largest number of this second network is 1, 1, which is 255, 255, right, at the end here. So it's from 4 to 7. Therefore, it created from, the first network is from 0 to 3. And the second one is from 4 to 7, right? From the 4 to 7 here. Okay, so it tells you the next network can be represented as 172.16.4.0/20. Or you can say this is 172.16.4.252, because 252 is /26. And you can see that the reason why you can quickly say this 252 from the /22 is that you can see that they have 2 more bits here, right? 2 bit plus 2 combination is 4. So 4 plus 252 is 256. It all added up to the total number of 256. Remember we mentioned that? From 0 to 255 is 256 numbers. So you can quickly figure out what the subnet mask is. And the IP address range for this 172.16.4.0 to 172.16.7.255. Okay, and of course you can, instead of using this way to say it, you can actually say it's 172.16.4.0/22, or you can say it's 172.16.4.0.255.252.0. And you should understand they all mean the same thing. And I believe we have did a very similar exercise in the first or second week of when we covered IPv4 regarding the 3 sets of the private IP addresses. We have went through this kind of representations for the same IP range in Subnet. All right, and this is the broadcast. We can say, hey, the quiz that will tell you that, hey, 172.16.7.255 is the broadcast address of the host 4.9. Is that correct? And you'll say, yeah, it's true, because hey, according to this analysis, right? All right, the next one is supernetting. We are going to supernet this one. So 172.16.0.0/12, including all the private internet address from 172.16.0.0 to the 172.31.0.0/16. So all these private 172 address, okay? All of this private address will be summarized in one word, in one actually sentence of 172.16.0.0/12. This network, if you say that, including all the IP addresses from 172.16.0.0 to 171.31.0.0, we supernet it, okay? And how do we figure it out? We're going to do this, /12, right? So 172.16, and you put 16 as a binary here, right? 16.0.0. And the focus will be on the second byte. That's why first byte, I don't care, I just put 172. And the last 2 is part of the host. So again, we draw a line on the 12th bit, okay? And the 12th bit is going to be in here. Let me just push it out a little bit here. And I don't know why, I think for some reason, accidentally, didn't write this correctly. Okay, so this looks much better. This is the subnet mask, right? So we drew it. This is /12, right? So this is actually 12 bits now represents the network. Yeah, we kind of reverse engine a little bit, and I don't mind. We just wanted to know this complex concept. So take a look at this. 172.16, and you have to be comfortable. This is 16, okay? 0, 0. So second by 16, 0, 0. So 16, 0, 0. So we only focus on the second, third, and fourth byte, okay? Now, smallest one, of course, is 00, which is the same as the 172.16.0.0. The largest one, we'll put in 1111 and then 255.255. So if you put in 111 here, now what does it look like? This is actually 31. You see that? 1 and then with 1111. So this is 16 plus 15, so that's 31. Therefore, if you use 172.16.00/12, it actually summarizes all the private internet address from 172.16.00. Each one is a class B, to 172.16.1.0/16, 172.16.2.0/16, all the way to 172.16, 172.17, 172.18, 172.19, all the way to 172.31. So all this IP private addresses from 16 to 31 class Bs has been summarized to /12. That's what this supernetting is about. Now, if you want to supernetting a 192.168.0.0 to /16, it will including all the private address of 192.168.0.0 all the way to 192.68.255.0. Each one is a /24, which actually is the whole class B if you think about it. 192.168.0 is a class C, right? And then 192.168.1 is another class C. No, I'm going to only talk about the third byte, okay? So 192.168.2, 4, 5, all the way to 255 here. That means actually all of those 192.168 class B network already been included, right? So the whole class C, the 256 of the class C, combined together into a one class B network, which is 192.168.0.0. So it's like a supernetting or route summarization. So let's take a look at with the same method that I asked you to use. And you will see that 192.168, right? And this time I'm not going to put in one in here. So you drew a line here. This is all the network, right? And then this is all the hosts in here. So look at the host, which is designated in the red color here. Smallest one is zeros. And then the largest one is 255.255. So you knew that if we use a /16 here, if we use a /16, then your smallest number is 0, 0, 0, 0. And your largest one is 255, 255. Okay? So that tells you 192.168.0.0/16 it summarizes, it aggregated, it supernetted, whatever you want to call it, okay? It combines all of the private internet address from 192.168.0.0/24 to 192.168.255.0/24. All of them has been combined, right? So you can see that actually, when you see a /16, you can quickly see that that means the first 2 byte is network, and then the third and fourth byte is the host. So that means, hey, it's one network. It combines everything in from the 00 to 255, right? So this is the most straightforward supernetting in here. So if we summarize it, the tables will summarize all the IPv4s. And you can see that from 10.0.0.0 all the way to the largest one, it's one single class A private address is a /8, right? And then for the class B is 172.16 all the way to 172.31, which is a class B, each one of them. And you can summarize it to this one, just like what we have designated, we discussed in our example. And that's the host ID is 20-bit in here, 16 plus 4 in here, okay? And then in here, it's half and half, 16-bit host and 16-bit network. And you can see the 192.168.0.0 all the way to 192.168.255 network has been summarized into a class B network in here, like what we have discussed. Now, the last one will be we subnetting a class A network. In the class A network, which is the first A, actually the first A bit of is the subnet mask. And now we just keep flipping all those bits. We actually flip it all the way to okay, so this is actually a real example I was talking about in the hospital. I was a consultant before, and they use a 255.252 slash network address. Actually, it's a /14, right? So /14, that's 8, 9, 10, 11, 12, 13, 14, right? So it's 255 with 6 of the ones here. And then I was looking at the host, which is 10, 10, 10, 10. And then, hey, which network am I belong to? What is my broadcast address? If I'm setting up a new host into this network, what IP can I use? So you're going to use a new IP that belongs to part of the 10, 10, 10, 10 network host. So that's a challenge. So let's take a look at it. You just go ahead and put down 10, 10, 10, 10 into it, and the focus will be on the second byte because it's a /14. So you drew a line on the 14th bit here, and on the left here, whatever the bit is a network bit, on the right side is the host bit, right? So then you take a look at it, the 1010 and 10.10. So that's the existing host. And I want to find out which network it belongs to. And the network it belongs to has to be the same network. Therefore, the network bit has to be the same, right? In here, it has to be the same. And the smallest number will represent the network it belongs to. Therefore, I put down 00 here, and this 1000 is 8. So that's why it's 10 dot, I didn't write the first byte, okay? 10.8.0.0. So the idea is the host 10.10.10/14 belongs to a network of 10.8.0.0/14. What is the broadcast address? Broadcast address would be largest one, right? Largest host, which is 11 here, with 11 and with all the ones in here. So it's 11.255.255. Therefore, you can derive the information and say, hey, 10.11.255.255/14 will be the broadcast address for the 10.10.10.14. 10.10.10/14. The broadcast address is this one. It by no means look comfortable or straightforward. This is the network it belongs to, 10.8, and the broadcast is 10.11. Okay, so that's the way it was set up. And if you wanted to figure that out, this is the way you figure it out. Go by the definition. Don't make it complicated. Just go by the definition and answer the question. Then the available number of hosts for the network, then right, if they ask you that question, then you see here available network host, right? So the host is here. If you take a look at it, the available host number here, and you can see that this is host number. This is the host number all the way in here. And of course, I cannot, let me highlight it. The available host number is all the way to here, right? It's the 00, and then with the 8-bit here and with the 8-bit there. So the 8-bit, 16, 17, 18. So you got 18-bit for the host. So it's 2 to the power 18 minus 2, of course. And that's a lot of hosts. I don't know who in the world will create a network like this with a 252,000 plus network host ID shared in one network. This is just no point of creating this /14 network, other than job security, I would say. All right, note to find a quick answer after we discuss the concept for this document is that when we created that, and you can see that all the number in here, let's take a look at the end first. All right, so this is the quick note in there that you can actually try to do a shortcut on that. If we do a /25, we just look at 1 byte. If you can figure class C, you can figure class B and A accordingly. So if you do a /25, which we did discuss in detail at the beginning of this video, then you say your legal subnet actually, well, you have to, this don't do the -2, okay? So that's why I said class 2. This is according to the RFC. So when you flip 1 bit, the original bit belong to the host now become network. Of course, it can be either 0 or 1, so you created 2 network, all right? And then legal host, you divide it to half, so it's 128, right? And the range is from 10 to 127, and 128 to 255. This should be clear and straightforward for you now. Now, if we flip 2-bit, which we also discussed in detail, so they are 2-bit that you created a new legal subnet. It will be 2 times 2 because 2 of those bit, it can have 2 times 2 to the power of 2 combinations. So you have 4 network, and each network will have 64. So you will see that. So the subnet range, you will divide the range into 2 range in here. For instance, if you flip 1 bit, your host become from 0 to 127, and the second half is 128 to 255. And if you further subdivided it into /26, then it become in this group. Then your network will be like in from 0 to 63, and 64 to 127, and 128 to 191, 192 to 255. And if you do /27, which we also discussed in there, now you have a group. So like in your handout here, this page, you will see on this page that we have talked about, then you are going to do it like, oops, I don't want to make it a big one, so I'm just going it on top. So you can see that from this big one, your 000, it will be the first group of the network you created is from 0 to actually /27, and that's actually 3 bits, right? So the subnet that you created, let me see, subnet host, this one we're talking about host. Subnet created, of course, is 8 of them. And each network, how many hosts do you have? Then we'll take a look at this one. We'll take a look at, now we think about this as a host. Sometimes this page you have to think about as a network, and sometimes you think about it as host. Depends on what the context, what are you trying to resolve the question. Now we're talking about hosts, right? So you can see that we have, for 3-bit is the network that we created. For the 000 network, then the largest one will be all the way to 31. That's 000, right? So it's 0 to 31, okay? And then from 32 to 63, so on and so forth. So you 1, 2, 3, 4, 5, 6, 7, 8, just like we have explained it. So the first one is, of course, this is actually /26. So I just carry it over, okay, from 26 to 27. So this is the 20. The last line here is the 27th, okay? And then if you do a 28, then it will be here. So this is like a checkpoint. Here, this I like to talk about is /28. /28 is like, the last byte, you have 4-bit for the network, 4-bit for the host. So each one get 16. 16 times 16 is 256. So you create 16 network, and each one has 16 hosts. And the 16 hosts, it will be from 0 to 15, 16 to 31, because you chop it to half again. The reason why I wrote down the previous one is that when you submit to here, you chop it to half again. From the /27 on top, it becomes /28. So you chop this one to half, 0 to 15 and 16 to 31. And here is from 32 to half is 47, and from 48 to 63. So it's like further subnetted from /27. So this is /27 on top, okay?
And then if we do a /28, it's like we chop it, we slide it, we subnet it to another half. Okay, so 16 hosts, 16 network. All right. So this is the end of this particular video, and please do watch this one. And then in class, we would not go over this detail again, but we will do other practice examples to further illustrate the concept and get you comfortable to deal with subnet and supernetting questions. Okay, thank you.